the solid solution strengthening. I forget to give this space. Solid strength. Solution strength. Okay, so the another technique to strengthen and harden material is the alloying with the impurity atoms that go into the either substitutional or interstitial solid solution. So what does it mean? I mean, you are just strengthen your material by introducing some foreign material or foreign atoms inside a metal, okay, inside a crystal, so that to increase your strength. How? You can either you can have the substitutional or interstitial. I have already made you know what is substitution means. If you have the lattice or you have a crystalline like this, okay. Now you have substitution means you have removed these atoms, okay, and you have set another one here at particular moment. I mean, you have not disturbed the neutrality. You have kept neutrality same, okay, but what you have changed just the replacement of atom you have done, okay, that is known as substitutional. Okay, interstitial means you have, I mean, you have not disturbed the crystalline structure, but you have introduced some foreign element or sorry, foreign atoms inside that crystal like this. If this particular space is present, you have just inserted that atom is known as your interstitial. I have already made in the point defects. What are the point defects? As you can see here, if I can come back, go back to the top, and I can see you. Yeah, yeah. This is substitutional. As you can see, you have replaced the atom, okay, some foreign atom you have placed here, and you have removed the word. I mean, in this case you can see all the white atoms are present, suppose in just a arbitrary name that I have taken, okay, and you have replaced with the blue one, okay. But in interstitial atom you have not disturbed the crystal structure. White are all present at their own, but you have inserted some other foreign atom at the places of the space which was left here like this. So this is your interstitial atom. So introducing such kind of things can make your material stronger, or you can increase your strength. You can increase the material strength, or make your material harder. Okay. So solid solutions are this like this. I mean, you can have. I mean, by introducing some impurities in your material, that you can increase the strength and hardness. I mean, though at the same time you are basically compromising some other properties as well, because imperfection in solid will reduce something, okay. So but at the same time, if what it depends on what the kind of the application that you are required. If your application is that you are interested to increase the strength and hardness of your material, then these kind of things you can do, okay. But at the same time, you are basically compromising your material in other way. Okay, so I mean your other mechanical property can be compromised at the same time. Okay, so according to this call, the solid solution strengthening. This is what we call the solid solution strengthening. Means you are just introducing some impurities, which is known as kind of the alloying. Okay, you are mixing, you are giving, you are inserting some other impurities. Okay, so high purity metals are almost always softer and weaker, as you can see. If they are impure, it means they are softer and weaker. Okay. Then the alloys. Alloys means if they have incorporated some other metal or other atoms. Impurities means what? Impurities means not, I mean, you are just providing the dust. It means they are I mean the atom that you are providing which is not of that family, which are I mean the parent material is made up of. Okay, so this is your impurities. So basically they are known as the alloys. So if we talk about the pure metal, they are always softer and weaker as compared to the alloy composite. Okay, composite of the same or base metal. Okay, because they have why? This is just because of the solid solution strengthening. Okay. So increasing the concentration of the impurities result in another attendant increase in the tensile and the yield strength. What at the same time you are increasing? You are increasing the tensile and yield strength. Okay. So alloys are stronger than the pure metal because the impurity atoms that go into the solid solution typically impose the lattice strains on the surrounding host metal atoms. You know what is the strain? Strain means the change in the position. Okay, you can how long you can stretch something. So change in the position by the original position, which is known as your strain. So what happened here? So the impose the lattice strains to surrounding host atoms. This is the name. So lattice strain fields interaction between the dislocation and these impurities atoms results and consequently dislocation movement is restricted. Okay, so what happens when you introduce a new other foreign element that will increase your lattice strains, and that lattice strain will not let your dislocation move further. That is, it means they will stop the dislocation to move further, and that's why you could have your material, increasing their strength. Because I mean, I have already made you know that I mean, if you are able to somehow you are able to restrict or stop the dislocation of material, okay, then you will achieve your strength. I mean, achieve your material, increasing their strength or hardness. So by introducing the atoms by substitutional or interstitial, you could have the lattice strains, and that strain will not let your material, dislocation to move further. Okay. Okay. So this is for example an impurity atoms that is smaller than the host atoms, for which its substitution exerts a tensile strains on the surrounding crystal, that is as illustrated in the figure below, as you can see here in the figure. Okay, so this particular atom is a smaller as compared. I mean, you can imagine this white one is are of the pure metal or the pure crystal structure, that I mean pure atom that is present in that particular crystal. Okay, and this orange has been introduced by by other any means. Okay, which you can say this is an impurity kind of things. Okay, so they have attracted all the atoms nearby atoms, okay, and they are in a compressive nature. Okay, so and what is the reason behind? Reason behind is the representation of the tensile a lattice strains imposed on the host atoms by the smaller substitution impurities. And what I mean, on this particular they are compressive, okay, but if we talk about the parent element, parent atoms, they all are in tensile. So they are in self in tensile, but on this particular foreign atom, they are basically attracting. So they are having in a compressive natures. Okay. Second one, the possible location of the smaller impurities atoms relative to the edge dislocation, such that there is the partial cancellation of impurities dislocation, that is strains. As you can see in this picture, I mean, see here, they have stopped. They have come here. This is the way, and they have stopped the dislocation movement. So this is the way you can increase your, you can stop the dislocation and you can increase your strength and hardness of your materials. Okay. Similar to that, the large substitutional atoms imposes, okay, compressive strengths in the vicinity of the shown there. As you can see, when if the atom is just bigger of that, I mean in what happened in first case. Yeah. The foreign atom was of a smaller size. So then in that case, they experiences the for the foreign atom experiences the compressive nature or compressive on itself, but the nearby the atom got tensile natures, or they have the tense, they are in tension. Just opposite to that, if you are introducing the atom which is greater than the parent, I mean if the rest all the this near about one atom, the white atom is of a smaller size as compared to this green one. Okay, so in that case just opposite the sense will occur. It means the Green wall will, I mean the foreign atom will experiences the tensile force, and the nearby all will experiences the compressive force. And that's why there is the just opposite to that. You can see here is your opposite sense. As you can see here, in the opposite, okay, I mean this is the your edge dislocations, right? Yeah, also this is the edge dislocations. But what happens in there? You have a due to the your compressive nature of other, I mean in crystal, they are making these kind of things, and that will stop your dislocation movement. Okay, so as you can see, the compressive strain imposed on the host atom means the crystalline structures atoms, I mean the atom which is present, okay, inside crystal. Okay, this is your large substitution impurities atoms, and the possible location of the large impurities atoms relative to another edge dislocation such that they are the partial cancellation of the impurities dislocation that is distant. So what happen when they are in other positions? They cancel to each other, and they are not able to. They will not allow the dislocation to move further, and in somehow you can see that, I mean it will resist the movement of your dislocations, and it's in a other way they are basically restricting your, they are increasing your hardness and strength.